The waste management industry has come a long way since the days of the backyard incinerator and the horse-drawn cart. Today, space-age technology is being applied to waste management systems, from the simple home trash compactor to advanced landfill gas recovery and energy generation plants like this one at the BKK Corporation's landfill in West Covina, California. It may be hard to believe, but when California first permitted BKK's 200-acre landfill for disposal of household waste in 1963, there weren't any homes nearby. Now several thousand homes have been permitted and constructed on the gentle slopes surrounding the landfill. Let's look at the consumer habits of the occupants of these and the other nearly 3 million homes in Los Angeles County, which annually create a mountain of trash weighing approximately 12 million tons. Commodities, home products, packaging, all create waste materials. Society today demands cost-effective products, and the waste byproducts from these goods have never been in greater quantities. An example of this is milk. Many of us remember the glass containers that were washed and reused. Today, milk is bottled in plastic or paper, creating more waste. That, for the most part, is unrecyclable. For a lot of us, the last time we think about our trash is when we have to put it out for pickup. But after it has been picked up from thousands of homes and industry, it becomes a massive daily chore to handle. As a municipal load enters the landfill, the first stop is the computerized scale house, where the load is weighed and recorded. The load is then directed to an area called the working deck. It is here that the trash comes to rest. The load is dumped, and large bulldozer tractors push and compact the trash into a pile approximately 20 feet high. At the end of the day, large earth movers called scrapers cover the material with a layer of soil. This daily deposit of refuge is called a cell. These daily cells comprise the matrix for the completed contours of the landfill. But the story of trash continues. For as the waste material decomposes, it creates a natural byproduct, methane gas. At BKK, the gas is collected in one of the most extensive systems anywhere in the world today. Over 100 gas recovery wells and 15 miles of piping throughout the fill collects the methane and delivers it to the on-site electric generating plant. Utilizing the gas for the generation of electricity also preserves using natural resources such as coal and petroleum. The BKK landfill, besides being a depository for municipal refuse, was also utilized for the disposal of solid and liquid hazardous waste products from 1974 through November of 1984. The great bulk of the deposited materials, however, have been non-hazardous refuge and soil. In November 1984, BKK elected to stop accepting hazardous waste. In accordance with the new federal guidelines under the Resource Conservation and Recovery Act, once a facility stops taking hazardous waste or reaches capacity, the hazardous waste disposal portion of that facility must be closed in a manner which will ensure its long-term integrity. Facilities shall be installed to prevent the escape of any waste constituents. These improvements must be designed in a report called a closure plan, which must conform to federal and state regulatory guidelines. The BKK closure plan represents the first major plan developed under the new guidelines and offers a challenge for the agencies and BKK. Agencies responsible for the review of the closure plan include the Federal Environmental Protection Agency, State Department of Health Services, State Water Resources Board, Regional Water Resources Control Board, State Solid Waste Management Board, State Air Resources Board, South Coast Air Quality Management District, Los Angeles County Health Department, City of West Covina. To help us further understand the impact of such a plan, Mr. Phil Boble, Chief of the Waste Programs Branch for the Environmental Protection Agency.
2 state agencies must approve the closure plan: the Regional Water Quality Control Board for Los Angeles and the State Department of Health. In addition, the Federal Environmental Protection Agency must approve the closure plan if the delegation of the state program hasn't occurred by the time the closure plan will be ripe for approval. These 3 agencies have spent the last year reviewing, commenting, and ensuring modification of the closure plan to achieve the one which currently exists. That plan is now ready for the official public comment period, a 30-day period at the end of which is a public hearing to take the public comments on the plan. Those comments will be considered by the agencies, revisions made if necessary, and if the comments aren't extensive, it would be possible to approve the plan with modifications as necessary within 30 days after the public hearing.
The key elements of the closure plan are final grading plan, final cover installation, storm drain facilities, gas collection systems, liquid management facilities, landscaping and irrigation systems, groundwater monitoring. Let's review each of these elements in further detail. First, the final grading plan. In November of 1984, when the landfill elected to stop handling hazardous wastes, the contours of the fill had not reached final elevation. This is necessary to provide for proper long-term drainage and installation of efficient gas recovery systems. In order to construct these facilities, a final grading plan was developed which required the continued disposal of household and municipal refuse on top of the previous fill area. Final contours, as designed, will be completed by placing household refuge until mid-1987. Maintenance roads around the fill will be built every 40 feet of vertical height as the slopes progress for long-term access. The next element of the closure plan is the final cover. As the final contours of the fill are completed, a clay cap will be placed over the entire landfill. The cap is being constructed using a 5-foot thick layer of compacted native material, which will be tested during construction to ensure that the design standards for the prevention of surface water intrusion and escape are being met. Approximately 2 million cubic yards of soil are required for this cap. In order to meet the standards of the plan, the soil must be screened to remove rock fragments larger than 3 inches before it is put into place. The next element is drainage facilities. Upon completing the placement of the final cover, storm drain systems consisting of bench drains, down drains, main collection pipes, and storm water retention basins will be installed. These facilities will provide for the rapid removal of surface runoff to prevent any intrusion into the landfill through the clay cap. The next element is the gas-to-energy recovery system. As we mentioned, when the waste material decomposes through natural anaerobic bacterial action, it produces a natural byproduct, methane gas. At BKK, the current gas recovery system is being expanded to include over 200 gas wells and over 15 miles of piping. The gas is collected and delivered to the on-site electrical generating plant or the flaring station for excess burnoff to control odors. This generating plant is utilizing state-of-the-art equipment to deliver up to 5 megawatts of power, which is sold to the Southern California Edison Company. In the power plant, the gas is used as the fuel to run turbine engines that in turn run the electrical generators. The revenues from this plant are planned to help offset the costs of closure and post-closure maintenance. The testing and monitoring of such a system is a never-ending task that involves taking readings from over 600 multi-depth probes surrounding the filled area. A special team of technicians perform these tests and submit their documentation to the Landfill Engineering Department for consistent record-keeping. The next element is the wastewater treatment facility. A major element of the BKK closure plan is to remove and treat any remaining liquids from the trash prism. These suspended liquids will be removed via vertical wells and piped to the treatment plant. The non-hazardous treated liquids will be used for on-site dust control and landscape irrigation. One of the final elements of the closure plan is the landscaping and irrigation system. Upon completion of the final cover and related closure facilities, the entire site will be landscaped to provide for a more aesthetic natural appearance. The landscaping will soften the contours of the fill and provide for erosion control. A 1 million-gallon water storage reservoir will be constructed along with a computerized weather station to maintain adequate plant moisture requirements without overwatering. The last element of the closure plan is the groundwater monitoring system. For over 2 years, BKK has been installing groundwater monitoring wells around the perimeter of the landfill. A total of 120 wells currently exist, and more are planned for the future. The wells have been placed around the landfill to monitor for any migration of liquids and to provide for extraction and treatment should that ever prove necessary. Most of the closure activities we have discussed are expected to be completed by the end of 1987. The estimated construction cost for these improvements is approximately $13 million. BKK will also provide maintenance of the cover and collection systems for at least 30 years. Details of how these activities will be performed will be described in the post-closure plan, which is currently being developed. The BKK Corporation has dedicated all of its technical and financial resources into the development and implementation of this closure plan to ensure full compliance with the new regulatory requirements. A critical element in the successful development of the plan was the continuing communication, guidance, and cooperation of the regulatory agencies. The plan represents thousands of hours of intense engineering and technical study, culminating in a document which could well become the textbook for future closure plans throughout the nation.